first thing first, before we start, remember that enthalpy is pretty much when you have a change. So we're going to quickly go to the theory, by the way. So you've got a change of energy or a transfer of heat. It's either exothermic, where as you go through the reaction, you've got heat being released or heat being lost into the atmosphere, and then like endothermic reactions is when you've got heat being absorbed and you're gaining heat as during the course of the reaction. Yep, remember that?
Yep.
Perfect.
I remember the little graphs too. I went through this theory at school.
Oh, well, I thought I'll just go through it quickly because it takes only 2 minutes, but I kind of get you into the zone. And then the last thing I want to talk to you about, remember we did this throughout when we did our first lesson. Remember that the specific heat capacity, 4.1.
Of water, yes, 4.1.
Yeah, perfect. Yeah. Cool. That's the only things I wanted to go through because I thought they were really important. All right. So let's start with your question the first one is you've got 20. All right, I should start actually typing.
Actually, the first one is the one above that. It's 50 mils.
Oh, well, I'm doing that second because it's all like I've sorted it out already.
All right.
All right. So you've got 25 mils of barium. Oh God, this is gonna be fun. Barium hydroxide. Do you agree? And you've reacted that with 50 mils of acetic acid. Yep.
Yep. That's a weak acid, isn't it?
Correct. Good job. It is a weak acid. That is important to note. So what we've got here written is and the important thing is with this acid, it's 1.5 moles. So that's its concentration, which we're going to use in the equation. And the last piece of information that you got given is your temperature. It rose. What does that mean if the temperature rises as the reaction occurs?
You've got, it's a exothermic.
Perfect. We're going to use that piece of information as well. So it went from 21.3 to exactly 34 degrees. Do you agree with me? Oh, wow. Why is it caps lock? Anyway, it's going to be caps lock. So your question is determine the enthalpy of neutralization. So by tradition, what is the first step you think I'm going to make you do?
Write the formula.
Yeah.
Actually, you can write the formula, but you can also make a balanced equation.
We're going to write a balanced equation. Yes. So as you can see, I am prepared. I have all my answers ready. So what type of reaction is this? You've got an acid and a base. What type of reaction is that?
It's an acid-base neutralization reaction.
That's what I was looking for. Neutralization. That is the word I'm looking for. So if you've got a neutralization reaction, what are the two products that you're going to form?
You're going to have since this is a salt and a water and some water.
Perfect. Ding, 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 ding. I'm proud. Good job. So we're going to be making, you've got barium hydroxide. Okay, we fail at typing. Plus, you've got CH3COOH. Do you agree? It's a straightforward reaction. It's not an equilibrium reaction. And we're going to form, as you told me, we're going to make water plus a salt. What is that salt going to be?
So barium, something, barium. Since we've got two there, one there. This isn't going to be balanced, is it?
No, that's step 2. These questions are kind of hard that your teacher gave me.
Because it's kind of like, I know barium's there, and then just looking which cation is not used already. So with that.
So we don't care about the cations, we care about the anions.
I mean anions, yeah.
Good.
Okay, so that goes with that. Barium hydroxide. Barium.
So remember how I told you is a cheap way of doing this is remember we've made water, so that means this hydrogen is gone and
is
the
it barium
hydroxide.
Carbonate?
No, where did you get carbonate from?
It's because C. Both. Two. No. It's a guess, basically. Trying to look.
All right.
Barium oxide.
No.
What is it? Oh, see. Oh, yeah, that makes sense because you've got the one oxygen. Okay.
All right. Let's do this because it seems like you're not getting the point. So remember, as I said, as a trick way of doing it, this is going to always stay, right? So you've got the same type of cation. Can you see? Barium. The only difference you're going to know is that if you're trying to find the anion as you were, you know that this hydrogen is gone and the O2 is gone because you've already used it. You've made water first. So whatever is left is going to be the anion of your acid.
Yep.
Make sense?
Yep.
And why have I put a 2 down here?
Because that's the amount of the 2.
Has nothing to do with amount. Has something to do with charge.
Oh, is it because it's -2, or is the entire charge just
No.
lost?
Remember crisscross method. What's the charge of the anion?
Oh yeah. So you got the OH there. That's 2. So then
So what the OH isn't 2. What is 2?
it's swapped. It's swapped charge, right? With that one.
So your barium is 2+, and your acetic acid is, can you see, 1-. So that means if you're going to do a crisscross, your barium is going to, okay, I'm going to write this down. Barium is 2+, and the acetic, CH3COOH, is 1-. So if you're going to do a crisscross, you're going to have Ba, let's say 1- CH3COO2.
Yep.
Make sense? Remember, this is why I keep hammering you about the crisscross method and about checking the charges of the anions and the cations.
Yep.
Really important because you know that your barium is 2+, your cation, and your acetic acid is 1-, and you need to swap the charges between them. Yeah.
Yep.
Perfect. Now let's balance this equation because it's definitely not balanced.
No. So we've got 1 barium, which is correct.
Are you writing this down, by the way?
Yeah. Yes, I am.
Okay, so what are we doing? How are we going to balance this?
So let's see. 2. So let me not count what we've got. So I've got 1 barium. Yeah, that's right. We've got 1 hydroxide there, and there's a 2.
So you don't do it by hydroxides, you do it by the element.
Yeah. Oh yeah. So we've got 3 on both sides of oxygens. 3 oxygens.
No, we don't. We have more.
Oh, we got
1, 2, 3, 4.
Oh yeah, of course, because of 2. So you got 4 hydrogens. We've got like 4 plus. We've got like 10
10 of
hydrogens.
on the left hand side?
Yeah, on the left hand side. So on the right hand side,
how do we have 10
got
hydrogens on the left hand side?
Because I got 4.
1, 2, 3, 4, 5, 6.
I thought I counted that oxygen as you can see, I'm probably quite tired. That's why my head's not quite on this up to speed. It's Friday. Yeah, 6. Okay. And then on the other side, we have only 4.
All right, I'm going to give you a clue. So
put a 2 there. Yeah. Okay. Isn't that pretty standard? Just having to put a 2.
Well,
what else?
You need to balance something else. Your left hand's not balanced. Here's your clue. You need to balance your left hand side. This is out of whack.
Okay.
So what are we balancing?
Need to know what else we need more of.
You've got it right here. It's the biggest clue. Can you see you've got 2 of CH3COO minus? Can you see you've got 2 of those? So you're going to put a
Yeah.
2 there.
Yep. Okay. But I thought that was the charge.
No.
Not.
Remember,
Oh, that's.
charges
Oh,
go up.
you were pointing to the minus one. Okay.
That's the charge.
Yeah.
Okay, so that is a balanced equation. Yeah?
Yeah.
Now, the first step to work out the enthalpy is you need to know how much heat has been transferred. Yeah? That's step 1.
Yep. So what does that change? Does it it tells us, doesn't it? It tells us it's gone from 21.3 to 34.
34. Correct. That's the
Yep.
temperature. So the first thing
Yep.
you're going to do is you're going to use this equation, which I'm typing right here, is M times CS times the change in temp. So temperature.
Yeah. M delta T. Delta T.
So you're going to get Q equal to bracket 25 plus 50. So the 25 plus 50 is coming from how amount? This is your mass. Your M is your mass. So I could actually write that down to make you not confused. Is your mass.
That's
so
your final mass, yeah.
75. Then you're going to times by, remember, your specific
Change
heat
in
capacity.
Yeah.
Yes, your specific heat. Yeah.
Yep.
And then you're going to do your change in temp, which is 34 minus 21.3. Yep.
Okay. Yep.
That is all going to come to.
Let me see.
Do you have your calculator with you?
Yep.
Perfect.
What'd you get?
I got an answer of 3,981.45 joules.
That's joules. Yeah.
Keep it
Because
in
we
joules.
haven't because we've got our temperature changes in is in just it's not in Kelvin, so it's in degree
Only in uni
Celsius.
will you get questions.
You don't need Celsius. I mean, you don't need Kelvin because
Yeah,
the
that's
change
only in
is
uni.
the same.
Don't even worry about that. So
Kelvin's but Kelvin and Celsius, like they both go up by just like by 1. It doesn't really matter.
Yeah, so you're in Celsius, so you don't really have to worry about the conversion of the temperatures. So remember, as we stated before, why I asked you that question is because this reaction is exothermic, it's going to be negative. Remember, we're releasing heat. You're losing heat. Does that make sense? Why it's negative?
Yep.
Perfect. Now, step 2. Damn, our little box is getting full. All right. Step 2. Hopefully this is logical, how I've broken it down, is you need to find the number of moles. You need to find N. And the only way you're going to find N is you're going to do mass. Oh, no, you're not going to do mass. You're going to do the molarity, so your concentration times your volume.
Yep.
So we're going to do, the only one that you got in the question is the concentration of, let me double check the question because I didn't write it down on my sheet. You got the concentration of CH3COO minus, so your acetic acid. Yep. So we got told it's 1.5 mole. So in order to work out N, we're going to do 1.5. You're going to times it by 0.75. Can you see how I convert that to liters?
Yep.
Remember, like SI units? Go with me?
Yep.
Does this make sense?
That's our mils. I mean, 1.5 molar. Yeah.
Yep.
Times our mils.
Yep. And then 0.075 liters.
Why is it the concentration of the acetic acid and not the barium
hydroxide
that you're using?
Question.
Also, it didn't tell you.
No, Your question doesn't state the concentration of barium hydroxide. It just tells you the amount of mils which we've already used here.
Okay.
When working.
All right.
So yeah.
They could both be
Usually,
1.5 molar.
That's what I
Aren't
said.
they?
No,
Don't
they're
they
not.
usually make them both the same?
No, absolutely not.
Okay.
I'll show you a question that I prepared, which is harder, and it's actually much more straightforward than the questions that your teacher gives you, which you've got both the concentrations, and then you have to make a decision as to which one you're going to use to work out. So in this situation, your teacher's like, here's a question. It's only got one concentration. That's what we're going to use. So you're going to get a value of N. Wait. Nope, I made a mistake. You didn't catch me making a mistake. Your amount is 0.075. Does that make sense?
Yep.
That's units, remember? Mole.
Yep.
Perfect. So we've worked out N.
Moles per liter. Moles per liter, isn't it?
Yeah. Last step is you're going to work out delta H. This is what we want to know. We want to see the amount of enthalpy, the amount of energy. So again, this is another formula, which is really good because it's just subbing in, which is Q over N. And we've worked that out already, that Q is this number right here. So you're going to do 3,981.45, which we worked out above in step 1, divided by the number of moles, which we worked out in step 2. And that's going to give us an answer of...
let me see. The person who actually called this cold off actually had himself tested for coronavirus. And
Wait,
it wasn't.
What did you
One of my
say?
friends who had called this cold off actually got himself tested for coronavirus, and it was not. So I have peace of mind.
Oh, that you don't have the virus.
Yeah. Number 3. Yeah, did you get 53?
I also got tested for the virus when I got sick in March.
Yeah, that's right.
All right, what did you get in answer?
It was not, hopefully.
No. No, it was just... What did you get as an answer?
53,086. Was it 5,386? Yeah,
no,
5,386.
53,600. 53,000. I can't speak English anymore. 53,086 joules. Yep. So if your teacher's really...
You just wrote 68.
Oh, yep. As you can see, my brain's also 86. So your teacher could be really pedantic, and they might ask you to have all your answers in SI units. In this case, you need kilojoules. So what we're going to do last step 4, is we're going to divide your joules by 1,000.
Yeah.
Just to make everyone happy. So your answer is going to be negative 53 kilojoules.
Yeah, you could do that earlier though, couldn't you? You could change it. You could change the joules to the joules when you have it.
Do you know why I don't like doing that?
Why?
Because if you're doing it in kilojoules, you're rounding off a lot of numbers because you're having whole numbers and no decimals. Can you see here where we still have 2 decimal places? It looks better and it's easier to round out at the end, being like, it's done, convert it to 1,000, it's over.
Yeah, you could.
All right, done. That's your answer. Was that helpful? Did you understand the 4 steps that we went through right now?
Yeah, I think so.
Okay,
I'm just going to write this down quickly.
Yeah, go for it.
I'm just quickly writing it down.
That's no worries, go for it. I'll shush for you.
Mm-hmm. And it was the bottom. What was it? Can you scroll down just a little bit?
Sure. Step 4 was pretty much just dividing by.
Yeah, 1,000.